Welcome to the embedded system class. In this video lecture, I am going to explain about I/O, multiplexing and GPIO control registers. So GPIO stands for General Purpose Input and Output Devices, meaning that it's a module capable of receiving and transmitting signals. So in previous classes, we have seen TM4C123 and 129 ARM processor. In 123 and 129 processor, we have different types of system peripherals like GPIOs, GPTs, hibernation module, watchdog timers, etc. etc. So in this video lecture, I am going to explain about what are GPIO control register, what is meant by multiplexing. So they work with digital signals but can be multiplexed to use the pins with other peripherals. So it is used in two modes, port mode and alternative mode. So we have different types of pins, right? In a pin diagram, different types of pins are there. So each and every pin will perform more than one function. So that is called as multiplexing. They work with digital signal but can be multiplexed to use the pins with other peripherals also. So this is GPIO mode. So the TM4C123 has 6 GPIO blocks, each with its own GPIO ports. So we have 43 channels, 43 pins in GPIO. So these 43 pins are categorized as 6 ports: port A, B, C, D, E, F. So in port A to port D, each port has 8 bits, and in port E we have 6 bits, and in port F we have 5 bits. Total 43 pins. The normal function would refer to GPIO, general purpose input and output mode. Means we can receive the data or we can transmit the pins, read and write the data. In this case, we can use these pins directly by writing and to reading from the relevant registers. So in many GPIO pins of microcontroller have alternative mode. Multiplexing means alternative modes or alternative functions. So in alternative mode, these functions would refer to other functions that may include. So it may include I2C, some like serial peripheral communication ports like I2C, SPI, UART, CAN, PWM, clock circuitry. So selected by GPIO control register. So in which mode it is operating, either it may be in port mode or alternative mode. So will be decided by GPIO control registers, right? So we use GPIO control register. So in which mode it is operating. The availability of some of such function depending on the pin can be seen in this table. So as for example, so port A. So port A is used. So we can use 17 to 24 pins. So this 17 to 24 pins, we can it will operate in general mode. So we use port A. So if it is in alternative mode, we use for serial communication ports, USB, I2C and SPI. So port A 17 pin in general mode is first bit in port A, and in alternative mode it used as UART receiver, right? So next 18 pin UART transmitter, 19 pin SSI clock, SSI slave select, SSI receiver, SSI TX mode, and 23 is for I2C receiver, 24 is I2C receiver. So that is about I/O multiplex. It means each pin will have two functions. So not a single function, we have two different types of functions. So these are the GPIO control register. A GPIO control register will give the information of different functions. So we have mainly 5 types of control registers: data control, interrupt control, mode control, pad control and commit control. So data control will give the information of which data. So it has two ports, 2 bits. So GPIO direction pin and GPIO data pin. If it is 0, then it will show the direction of and means which is device is acts as transmitter, which device is acts as receiver. And GPIO data, so whether we are reading the data or writing the data. So next, second control register is mode is interrupt control. It will give the information about interrupts. GPIO interrupt both edges or event edges or edges. Interrupt in edges or interrupt with in events. So next, third one is it will give information regarding mode of operation, in which mode it is operating. Either it may be alternative function mode or it may be port mode. So GPIO AFSCL means alternative function select. GPIO PCTL means general purpose IO port control register. So next port register is pad control. It will give about information about applications, different types of application. So we are using pull up resistor or pull down resistor. So we can using digital enable or not. So we can calculate slew rate. We can find the slew rate using GPIO SLR. We can find open drain configuration. We can drive strength. We can calculate drive strength also using GPIO DR2 or DR4 or DR8R. And last control register information is commit control. So whenever alternative any accidental hardware errors occurs, then these two pins will be operates. GPIO clock and GPIO commit. These are the different types of control registers we have. Thank you so much.